This topic is the backbone of number work. It powers fractions, algebra, sequences, and many real-world word problems. A factor divides a number exactly. It fits in with no remainder. Think of factors as numbers that go neatly inside another, like puzzle pieces fitting perfectly together. A multiple is what you get by multiplying a number by whole numbers. 2 times it, 3 times it, 4 times it, and so on. Multiples grow bigger, while factors break numbers down smaller. Just remember, factors go in, multiples grow out. When listing factors, always work in pairs. It helps you spot them all. For 12, start with 1 times 12, then 2 times 6, and 3 times 4. Once the pairs start repeating, you've found them all. That gives the full list of factors, 1, 2, 3, 4, 6, and 12. Multiples go on forever. We use them to find common multiples, such as the least common multiple, the LCM. Here are your quick divisibility checks, perfect for saving time in exams. If the last digit's even, the number's divisible by 2. If the sum of the digits is a multiple of 3, it divides by 3. If it ends in a 0 or a 5, it divides by 5. And if it ends in 0, it divides by 10. Use these quick tests before prime factorization. They make life so much easier. A prime number has exactly 2 factors beyond n itself. Break numbers into prime powers. 24 is 2 cubed times 3. 60 is 2 squared times 3 times 5. From the prime factor form of a number, you can even count how many factors it has. Take each exponent, add 1 to it, and then multiply all those results together. That gives you the total number of factors, including 1 and the number itself. It's a powerful shortcut that saves time in harder questions. For example, 24 is 2 cubed times 3, and 36 is 2 squared times 3 squared. The common primes are 2 and 3. Take the lowest powers, 2 squared and a single 3, giving a highest common factor of 12. For example, 8 is 2 cubed, and 12 is 2 squared times 3. Include every prime that appears using the highest powers. 2 cubed times 3 gives a lowest common multiple of 24. Let's find the highest common factor of 24 and 36. Start by writing each number as a product of its prime factors. 24 is 2 cubed times 3, and 36 is 2 squared times 3 squared. For the highest common factor, take the shared primes with the lowest powers. That's 2 squared and a single 3. Multiply them together, and the highest common factor is 12. 8 equals 2 cubed, and 12 equals 2 squared times 3. To find the lowest common multiple, include all the prime factors that appear, using the highest powers. 2 cubed times 3 gives 24, so the lowest common multiple is 24. 45 is 3 squared times 5, and 60 is 2 squared times 3 times 5. For the highest common factor, take the primes they share, 3 and 5, using the lowest powers. For the lowest common multiple, include every prime using the highest powers. That gives 15 for the highest common factor and 180 for the lowest common multiple. 84 equals 2 squared times 3 times 7, and 126 equals 2 times 3 squared times 7. For the highest common factor, take the shared primes using their lowest powers. That gives 42. For the lowest common multiple, include all primes with their highest powers coitus. That gives 252. Use the highest common factor when you need to group or share things equally. Use the lowest common multiple when events repeat or coincide at the same time. 18 apples and 24 oranges need to be shared equally. The highest common factor of 18 and 24 is 6, so they can be divided into 6 equal groups, each group getting the same number of apples and oranges. Bus A arrives every 8 minutes, and Bus B arrives every 12 minutes. We want to know when both buses will arrive together again. The lowest common multiple of 8 and 12 is 24. So, every 24 minutes, both buses reach the stop at the same time. This is Euclid's algorithm, a fast way to find the highest common factor using division remainders. Start by dividing the larger number by the smaller one, and record the remainder. Then divide the previous divisor by that remainder and keep repeating. When the remainder finally becomes 0, the last non-zero remainder is the highest common factor. Here, the process gives us 18 as the highest common factor of 252 and 198. three prime factors, 2, 3, and 5. Each power tells how many times that prime appears. To count all factor combinations, add 1 to each power and multiply them together. 3 plus 1 times 2 plus 1 times 1 plus 1, giving 24 total factors. Be careful not to mix up the highest common factor with the lowest common multiple. They answer very different questions. Always use the correct powers in prime factorization, smallest for the highest common factor and largest for the lowest common multiple. And remember to include both 1 and the number itself when listing all factors. Write your prime factors clearly and use exponents to keep your work neat. State whether you're finding the highest common factor or the lowest common multiple, and always box your final answer. Clear, well-organized working makes it easier to earn every mark. To summarize, the highest common factor takes the smallest powers of each prime, and the lowest common multiple takes the largest powers. For example, if one number is 2 cubed times 3 times 5 squared, and the other is 2 squared times 3 cubed times 5, then the highest common factor is 60, and the lowest common multiple is 540. Pause here and try these yourself. When you're done, check the answers in the description below this video. Well done! You've mastered factors and multiples that's real GCSE power. Keep going and subscribe to sharpen your maths super skills every week.